This video, I want to talk about the idea of positive work and negative work and what's the difference, okay? And also no work, all right? So, what if you're a skater, right? And say for example, she's a lady and she's moving in the negative x direction. Her displacement is going negative x, right? And as she reaches her partner pushes her with a force in the positive x direction. My question to you is, the work that her partner does, is it negative or positive? Or is it zero? Well, because there's some sort of displacement, we know the work cannot be zero. But here's the takeaway. Anytime your force and the displacement is opposite, you're going to do negative work. You're going to do negative work. So in this case, he did negative work. He did negative work on her. She's moving in negative x direction. He pushes her in positive x direction, and so he does negative work. Now, conversely, what if she's moving, what if she's moving in the negative x direction, and he pushes a foot, he applies a force to her in the negative x direction? What type of work is done? In this case, we've done positive work. He would have done positive work on her. Yeah, there's some sort of displacement, and the force and the displacement is in the same direction, and so that's what we consider as positive work. And so, vice versa again. What if in this case there's some sort of force going in this direction, and there's some sort of displacement going in this direction, delta r? Well, again, the fact that the force and the displacement is going in the same direction, we've done positive work. Vice versa, right? If you're in an aircraft, okay, so let's say this is an aircraft, okay, you're in an aircraft and you jump out, right? So an aircraft is flying and you jump out. So there's my stick figure. Okay, he's flying down. Yeah. And on test, if I were to ask you, okay, well, what is the work done by gravity? What is the work done by the Earth on my object, the guy? Would it be positive or negative? Well, obviously, we have some sort of displacement because we're moving. So there's our delta R. But gravity is also pulling down. So the force of gravity is also pulling down. And so therefore, this would constitute positive work. Okay, so this would constitute positive work. So again, anytime your displacement and your force is in the same direction, whatever it is, you've done positive work. So let's talk about the idea of no work. And you could have no work in two situations. No work done, okay? You could have this when there is no displacement. There's no displacement, okay? And also when the force applied is perpendicular to the motion. So these are the two special situations we're going to have when there's no force. And so if you can imagine no work, I'm sorry about that. And so if you can imagine, if this is a surface here, we have a block with some sort of mass, right? And you come along and you push on the block, but the block did not move. Well, the change in displacement is zero. Therefore, no work has been done. Okay? Because remember, the way we describe work is that the work is equal to the force dotted into the change in displacement. Well, if the change in displacement is zero, well, anything times zero is zero. So therefore, the work done is zero. That's one way of having no work. Okay, another way of having no work is when the force is actually perpendicular to my displacement. And so if I'm looking at this, what if we have a block on a surface, okay, and it has some sort of displacement in the positive x direction. So say for example, the displacement is 2 meters, okay, that's long, it's long, but say for example, the displacement is 2 meters. My question to you is, what would be the work done by gravity? Well, look, the displacement is going straight across. Yeah, it's going straight across in positive x direction. Well, the force of gravity is actually pulling it down. The force of gravity is actually going straight down. And you can definitely see that these are very perpendicular. And so therefore the work done by the Earth on a box would be zero. Okay, gravity would not affect uh, the work, there would be no work done by gravity. Okay, and that's the idea. Okay, whenever your force and your displacement is perpendicular, then you have no force. Okay. So now let's talk about how to find work. So I have this problem here, and it says a 20-kilogram object moves from the position as a vector to a different position while you exert a constant force. Okay, so they gave you the force. Okay, so they gave you the positions, they gave you the force. How much work did you do on the object? Well, starting from a principle, we know the work done is equal to the force dotted into the change in displacement. Okay, so we know the force. Okay, so work is now equal to the force, which is 15, -6, and 10. And we're gonna dot that into the change in displacement. Okay. Now, what's my change in displacement? I got to take the change in displacement is just R2 minus R1. So the change in displacement is R2 minus R1. So the last position minus the first position. And so if I'm looking at this, if I'm looking at this, I take 7 minus 4, so that would be 3. Okay, so then I'm doing my change in position. Okay, so 7 minus 4, 7 minus 3 in the x direction, that will give me 4. And then -3 minus 4. Well, minus 4, that's plus 4. So -3 plus 4, that will give me 1. Okay, so is everybody okay with that? Okay. Okay, so again, the change in position, so the change in position, okay, is always R2 minus R1. So now that we have this now becomes a dot product. And so if I'm looking at this, remember, work is a scalar, it's not a vector. And so if I'm looking at this, this is 15 times 3, yeah, plus -6 times 4 plus 10 times 1. Okay, if I'm looking at this, well, 15 times 3 is what? That's 45. Okay, well, that's nice to know. Well, since I have a negative sign here, we know this is going to be a negative. And so 6 times 4 is what? -24. And then we add a plus 10. And so if I'm looking at this, we have 45 minus 24 plus 10, right? What is that equal to? That will give us approximately plus 31 joules. Okay. So again, notice the work done is not a scale, is not a vector, it's a scalar. Okay, so here's my answer. So that's how we deal with the change in work, and that's how we explain the idea of positive work versus negative work.